So what am I saying? I am saying that depending on which row is to be selected, I will actually place my gate. You see what is happening? When I put my poly over here, this line got connected. When I place my device over here, this line got connected. Then this line got connected. Then this line got connected, and so on. This is fine? Or do you see any challenge there?
एरिया वेस्टिंग सर,
एरिया तो आपके उतनी नंबर ऑफ लाइंस थी, वो तो आपने प्री डिकोडिंग डिसीजन से ही वेस्ट कर दिया. What else? No other problem?
Sir, we will not be able to share the diffusion.
That you will anyways not be able to do. Why? Because you tell me, can you share the diffusion of this row with that row?
No, not between the rows, sir, in the same row.
So over here also, how will you share this diffusion? Not happening. है ना? So what else? Anyone who knows about Nwell proximity effect? No one has heard about Nwell proximity effect? See, we discussed about the fabrication process in our previous course. So how are Nwells fabricated? Who can describe that to me? How are Nwells fabricated?
On P-well, first P-well is created. On top of it, ion implantation is done to create Nwell.
Directly, P-well के ऊपर ion implantation.
No, you first need to use photoresist to remove that layer.
Okay. You have a photoresist, then you will expose this, and you will remove photoresist from some places. Am I right?
Sir. Yes, sir.
And then you will do implantation.
Yes, sir.
So let us say this is where you want to make, this is where you do not want those Nwells, or let us say this is where you want Nwells, kuch bhi, okay? So what happens in reality, the boundaries of these wells, this H is done at a slant, will anyways happen at a slant because of the depth.
Yeah, anisotropic.
Anisotropic, है ना? So what happens is that when you do ion implantation, there will be ions that will fall like this. Those that are falling on this line, on this edge, would get reflected. Are you able to see this? So I wanted my doping to be of one particular level, that there should be only, say, in this unit area, I actually wanted only 4 ions to go. But due to reflection, how many ions are going now? In this photo,
7
are going. So what has happened? The doping of my P-well and my Nwell has changed.
Yes.
So when the doping changes, what happens? The ease with which I can make my inversion layer or anything would change. So what happens? The VT would be different. So what is observed is that in a layout, if there are transistors which are placed very close to an Nwell boundary, let us say this is the Nwell boundary, then this transistor would have a different VT than this one. And this is known as Nwell proximity effect. Well proximity effect, sorry. WPE. Okay. So what we need to do is we say that I do not like this behavior where in some post decoders there is more proximity effect and in others there is lesser. So you're talking about the same bus, but in the same bus, some have more proximity effect, some have lesser proximity effect. I don't like this. So the farther bus is far away, may not bother me. But this bus which is close to the Nwell, this is a botheration for me. I don't like this. So what I do is, this particular bus, I put all the NMOSes equidistant from the Nwell. But then how do I do the programmation? I do the programmation by running a vertical metal, running a horizontal metal, and then putting vias or contacts like this to achieve the desired functionality again. Are you able to see this? Hello? So over here, so in the first instance, in this particular example, what were we programming? Depending on which row I am talking about, I was placing this cell somewhere. This device, I was placing devices. Whereas in this one, I am placing vias. So this is via programmation. Now again, do not confuse it or do not confuse it with the ROM programming, because that is not what the intent is. The user cannot change the programmation at any point of time. This is internal to the memory. But over here, we are programming only through vias, and the DRC rules that we need to manage could be much simpler than if I would place devices like that. Okay, so I would prefer to program with vias over here. So what I could do is I could make a cluster of 4 word lines each. This part would be static. This part would also be static. And in fact, what I could do is, instead of running my metal horizontally, I could simply have 1 vertical metal and 1 horizontal metal instead of 4 horizontal metals there. So instead of making this as part of 4 different cells, I could just make one cell where this is my cell boundary, you may say. Any questions?
Sir, when you are moving to this another metal layer, so this you're doing your via programmation, but then you said that we can using separate devices. For the each kind of block, we are using each one device only.
Sorry?
So like when earlier you were using the device programmation, right? You were placing devices जहाँ पे आपको place करना था, but आपने अब बोला कि हम via programmation करेंगे. But अभी भी हम devices तो हर एक वही लेंगे ना, मतलब device तो हमारे same रहेंगे, but आप
Yeah. We just kept them at equal distance from the Nwell.
yes sir. सर फिर आपने वो केस बताया जिसमें आपने horizontal vertical वाला बताया, वो चीज सर क्या थी सर?
That was, so see, I could make 4 cells, or I could still make just 1 cell, and program this NMOS and this via, 2 things per cell. I could do this, or I could say that, see, this arrangement is constant. So instead of programming this arrangement also, let me define one cell such that it has 4 word lines as the output. Okay, and then in every cell, this arrangement is static. Only thing that I now need to program is these vias. यहाँ तक clear है? Is this clear till here?
सर आप दोनों को like merge कैसे कर रहे हो, वो चीज clear नहीं हो रही सर.
Merge कहाँ कर रहा हूँ मैं?
लेफ्ट वाली सर, लेफ्ट वाले और राइट को क्या देख रहे हैं सर, मतलब?
See, I have to program both the buses, na? I have to connect A0, A1 bus also and A2, A3 bus also.
Yes, sir. Yes, sir.
So in one case, I say I will program both simultaneously.
Yes. Yes,
In
sir.
another case, I say, okay, let me use clusters of 4 rows and define a cell or define a repetitive block which has 4 rows in it. So minimum increment on any row decoder could be 4 rows. You cannot have a 33 row instance. You can only have 32 or 36 row instance. When I do that, what happens? I have made this programmation fixed. Now this no longer needs to be a programmation. I can actually design it like this.
Right, sir.
Okay. Now, if I have to design it like this, I designed it. Now look at it over here. There are 4, I have made 4 horizontal metal lines and I'm placing 4 vias. It may appear that, oh, I don't need to really put 4 vias. I can actually have just one vertical line connecting to all the gates. Okay, connecting to all these gates, and only one horizontal line which would connect to a via. The other 3 horizontal lines are not needed. And I would save overall capacitance on this global line.
So, but like connecting via only on one vertical line, I will have one word line connection, right? But for the rest of, how will we managing the rest word lines?
If there is a vertical line that I am running here, I can connect all 4 now.
Yes.
Anyways, I am connecting all 4 together. They're anyways getting shorted with the same line. Do you see this?
Okay, yeah, right. Yes, sir. Yes, sir. Yeah, got it, sir.
So I can actually reduce overall capacitance of the global lines. So see, address decoding is not simply a 2 to 4 decoder and 3 to 8 decoder decision. The layout also has a very significant impact on your sizing finally. So when you design the layouts in your projects, you have to be careful about what is happening on the overall scheme of things there. What is happening to the other stages of my design elsewhere. Okay?
So, but यहाँ पे एक और चीज आ गई थी कि capacitance of a like metal vertical running a vertical metal is kind of less as compared to like programming 4 vias. तो वो भी हमें ध्यान से देखना पड़ेगा फिर as compared to layout फिर.
It is not just 4 vias. Look at it. Over here, as of now, I have 4 horizontal lines and then 4 vias. What I am saying is replace it with one horizontal line, one vertical line, and one via. That via could be here, 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 or here. So overall metal is lesser. Moreover, in the row decoders, the overall height will be much lesser than the width that you will need to travel.
Sir, our current number of via would be same as previous.
No, there will be only one. So over here, via was dropped here. In the next rows, the via was dropped here. In the next row, the via was dropped here. You see? So, but only one would come at any point of time. In some row decoders, this will be like this. In another row decoder, this will be like this. In another row decoder, this will be like this. And another row decoder, this will be like this.
Sir, so what we are suggesting is that although it's a repetitive cell, but in each cell we are modifying them by interconnecting with metal and programming via different position, and also reducing the length on the right side, like where the metal is not required. So it's kind of a standard cell, but we are modifying it.
No, nothing in memory is a standard cell.
Okay, sorry, sir, sorry.
Nothing
So
in memory.
basically, sir, we can, even if it's separative, we can reduce the extra metal length, like in A2, A3 bar and A2, A3.
Yeah. So the important thing is that when you, in a memory, you have the flexibility. See, what did we do in the memory cell in optimizing the area of the memory cell? We said, I will optimize it as an array. The entire inverter for the right driver that we had to use, we pushed it in the IO region. You remember?
Yes, yes.
similarly, I am saying in memory periphery also, you can look at optimization beyond just one cell. Consider 4 cells in one go and then design so that you can save area, you can save power, you can save capacitances. That is all that I'm saying. That is the only point. That similarly, the thought process can extend beyond just the memory array into the periphery.
Right.
Okay.
Sir, I have one doubt here, sir.
Yes.
So basically, the static part which is fixed over there, the poly will be connected to the vertical M1 lines. Suppose if we
Yes.
consider that as M1.
Yes.
Whereas for the programming section ones, the poly will be connected to the horizontal M2 layer, and there will be a via between the M2 horizontal and the vertical A2 bar, A3 bar.
So first, in this kind of a setting, how do I put it? In this kind of a setting, M2 will typically be vertical. It is an M2 that these lines will run.
Okay.
Okay. Horizontal routing will be M1 and M3.
Okay. So
Okay.
in this case, the programming part, programming section, the poly will be directly connected to the M1, and there will be a via between M1 and M2 to connect to the decoder line.
Yes.
And the static part will be, the poly will be directly connected to the M2 layer.
Yes.
Okay, understood, sir.
Directly means through a metal one stub.
Yes, yes, sir.
Okay. So this is how your programmation cell would look like. There will be VRs like this. So your full layout would look like this, but the programmation cell would look like this. You will create a new cell. You will generate it through a script which would appear like this. Okay. You will simply overlay this cell over the row decoder array to make the required connections. So we will stop here. We'll come back to you with more details on the course project soon. And we can have a short discussion on course project in the next class also. In the meantime, I would want you to form teams before the next class happens. Okay. Any questions? Any pending questions?
Sir, one very basic doubt. It's just for sake of that row decoder would be out of memory, or because the area of the row decoder is very high. So should we kept the row decoder inside the memory itself or outside the memory?
So can you have a memory without address decoding?
No, sir. But
The
overall,
answer is there, na? Without a row decoder, you cannot have a memory.
yes, sir.
So what is left?
Means I am confused in which part we put a row decoder. Yeah, it would be yes, sir. Yes, sir. It would be in control part and X decoder part.
X decoder part है ना? Control part में pre decoding हो जाएगी,
Yes,
X decoder part में post decoding हो जाएगी.
Yes, sir. Yes, sir.
Sir.
Yes.
Sir, we have 4 vias on the right side, like on the A2 and A3 lines. So if we were talking about reducing them to one only.
Yeah.
So sir, won't it impact the performance? Because we have like 4 connections here. So if we were earlier, we talked about four resistances in parallel versus one resistance.
Yeah. So what kind of current or what kind of load does this VRC?
VRC is okay. 1, 2 NMOSes, gates, poly maybe.
Some poly gates, 3 or 4 poly gates at most, nahin?
Yeah.
That's okay, Deepank.
Okay. I was imagining like a bigger case where there are more word lines.
Even if you have that, see, any post decoder, only a few gates, on small gates will be connected to it, is it not?
So okay, got it.
Memories areas is very, very important. I do not want to put 2 VRs or 3 VRs and waste area because of DRCs between those VRs.
Oh, right, got it.
So we have to be minimalistic at places which are repetitive. See, things which are getting repeated, you have to be minimalistic. Things which are being added only once or twice or a very few times, or which are very, very critical for robustness. For example, sense amplifier, it's analog in nature. Such places you give area. Control region, you are okay to give area because just once it is coming, or just 3 or 4 times it will come if it is a hierarchical architecture. But something like a row decoder, which is repeating every row, be frugal.
Got it. Getting it.
Yeah.
Thank you.
Okay.
सर एक लास्ट डाउट था सर, जो स्टार्टिंग मैंने पूछा था, तो जो पेज सिलेक्शन है और जो बैंक सिलेक्शन है, फॉर एग्जांपल जो पेज सिलेक्शन होगा दैट विल बी अ पार्ट ऑफ माय रो डिकोडिंग, राइट? मतलब उसी से हो रहा होगा, राइट? इफ आई एम
कैसे
यूजिंग
होगा? रो pages would select different page, like page decoding means different pages are selected. You're not changing the row selection there.
ओके सर, बट व्हेन आई से पेज सिलेक्शन, मैं अलोंग द रो ही देख रहा होता हूं ना, राइट? अलोंग द रो ही डिफरेंट
I
पेजेस हैं
split
हमारे।
along the row, but it
Okay.
is not row. There are only 128 rows per page. So how can you have the extra bit there? है ना? Page decoding is different. That is a different level of just 2 pages, then 1 to 2 decoder ही चाहिए and you decode it. खत्म बात. Why confuse it with row decoding? Row decoding is separate.
सर बट एक पेज में एक
Did
ही
we
रो
even
होगी ना?
talk about column decoding when we were talking about row decoding?
नो सर।
Because they are different decoders. So page decoder is different than the row decoder.
सर बट एक पेज में हमारे वर्ड्स डिफरेंट हो सकते हैं, बट वो एक रो ही, एक पेज एक रो की कॉरेस्पॉन्ड कर रहा होगा ना? like एक रो में हमारे मल्टीपल पेज हो सकते हैं, बट मल्टीपल रोज हमारी एक पेज को कॉरेस्पॉन्ड नहीं कर सकती ना?
क्यों?
सर बट मल्टीपल रोज,
What did we see in that example that we were discussing? We saw that if there were 1k rows,
यस यस,
we saw that if there were 1k rows, what was happening? So 1k words per row. So mux 8, it means every page had 128 rows, na? So one page is corresponding to so many rows there.
राइट, ओके, यस।
है ना?